Hello, guys. I'm Javier Gonzalez, and welcome to the first episode of this Behavior Trees and AI programming series. First of all, we're going to check this lesson outline in order to organize our minds and know how we're going to proceed today and what we're going to achieve. So, first, we're going to start doing a really simple and short showcase of what we're going to program today, and then we're going to check the objectives, what we want to learn today and how we're going to learn it. And after that, we're going to go straight to programming, knowing and studying the basis of what AI programming is in Unreal Engine. And as point 4 says, we're going to check what the Unreal AI system has to offer and how we're going to implement that in our Blueprints project. Of course, the Unreal AI system is mostly behavior tree based, so we're going to check what this behavior tree has as elements. What is a behavior tree composed of? Um, and then we're going to jump into the conclusion of the lesson in order to check what we learned and how we implement it and how we're going to proceed in the next episode. Okay, so let's go straight to the showcase and the objectives. Today we're going to code a really simple AI which will chase us. Of course, we don't have AI perception yet implemented, but it's going to go straight to us. It will have a radius, an acceptance radius, and then it's going to wait. We're going to do all this with our AI controller and a really simple behavior tree, which we're going to extend on the next lessons. And it will be the first part of this series. Okay, so the objectives of this lesson is first understanding the foundations of the AI system that Unreal provides us out of the box. Then we're going to understand the behavior tree nodes in a real simple way, and then we're going to check the requirements for an AI implementation in our project or every project. I'm trying to do this as modular and simple as possible in order for you guys to be able to implement this in your game project or whatever you guys want to do with AI. So, in order to do that, we have to understand what Unreal Engine 5 AI tools has to offer and the elements it has within that system, which comes out of the box. So, let's jump straight into the AI programming. Okay, let's see. In these 5 points, which is really it's a really broad explanation, but it's basically what we have to understand in order to start developing an AI system. So first, it requires a nav mesh. As we can see here, we have this green sort of thing on the floor. That is a navigation mesh. This is basically we're going to see it more in depth here, but it's basically the place where the AI can act and can walk or jump and do stuff. On point 2, of course, this starts with system called behavior tree and a blackboard, which of course we're going to see here more in depth. And this can be easily debugged with Gameplay Editor and Visual Logger. We're going to see this more in depth maybe in lesson 2 or 3 when we start developing more complex behaviors on our AI and we want to see on screen what's happening like behind the scene. And point 4, ideally, this is based on my developer experience. The base is on C++ and the extensions are on Blueprints. What I'm talking about the base on our core logic and our core components when it comes to AI. We most of the time, of course, not in the series for the sake of simplicity, we're going to do this on Blueprints, but on a regular basis, you want to do the core of your AI systems on C++ and then extend that on Blueprints. The core, I'm talking about the tasks the behavior tree is going to execute on services and those more sort of tick operations. But that's a bit more complex stuff, but it's always good to have that on the back of our heads. To have this in mind before I start implementing and our planning stages on what comes to systems development. And the point 5 logic of the behavior tree is based mostly on tasks, on services, and decorators, which we're going to check on the next slides. This image here is a behavior tree. This is how a behavior tree looks like. It's really similar to a binary tree for those uh, who are closer to computer science, but yeah, it's basically this sort of trees with branches and leaves. It has an execution order which we're going to learn today, but yeah, this is basically how an AI system in Unreal Engine Blueprints looks like. So let's go to the behavior tree elements. As I said before, we have a navigation mesh which gives data about the boundaries the AI can move and act within, a pathfinding. What I'm talking about this is that of course you have to. I'm going to delete this. Nav mesh bounds. Yeah, we have our levels going to look like this. We go here and search for navigation mesh. Nav mesh bounds volume. We can check the description here, which nav mesh bounds volumes are used as a way to control where nav mesh will be calculated in a level. If you want like a more easier to understand explanation, is basically as I said, as I read on the slide, it's the area where the AI can walk and execute actions and basically go to. As we see here, of course, it has different parameters on how steep it can walk, but this green space is where the AI can go to. If you don't see it on your viewport, you can press the P letter, and it's going to be shown. Okay, then we have the behavior tree. We're going to this really simple behavior tree, which this is the brain of the behavior. Executes from top to bottom and left to right. So it starts on the root, moves to the sequence, and this executes from left to right. This is the execution order I was talking about before. Then we have the blackboard, which is the memory of the brain. Our brain is the behavior tree. It stores variables used in the behavior tree, but not logic. All of our logic is going to be executed in this behavior tree, in tasks and services, as we're going to see further in the series. Our blackboard can be checked here. We can see here it has different variables and it stores values. So the behavior tree is going to retrieve, fetch these values and pass it to our tasks and services, which is a periodic logic which we'll use later for our enemy detection. Then we have a blackboard, the composites. The root of a branch, and it defines the rules of execution. We're going to see this further here in the elements in depth, but the composites are this sequence and selectors. This is like, as I said before, the branch of every logic that we're going to run this behavior tree. So this is basically composed of composites and then these leaves, which are going to be our task or services and so on. And point 5, yeah, the logic is based on task, services, and decorators. As I said, is what the system is composed of. So yeah, let's go first. I'm going to explain here really quick what's happening. I have this small AI pawn. You can have this on Paragon. It's a Paragon asset. So we're going to open this. It's a character, and it has by default this character movement. This is what we're going to use later in the series. But this needs to have a controller. The controller is basically what's going to run this behavior tree. So we're going to go to this component, this controller, and you don't have to do a lot here. So what we're going to create our behavior tree. I'm going to show that in a bit. But what this does is that we manually expose this variable and assign a behavior tree asset to it. Then we have this run behavior tree function, which you can find in the context search, which is going to execute and start running this behavior tree that we're going to create. And after that, we assign a value to our Blackboard component. You can create a Blackboard asset, but most of the time it creates with the behavior tree like simultaneously. But we're going to use this later in order to assign values to this Blackboard, which was the memory of our brain, and the brain will fetch this information. And this delay is basically to wait for initialization. Remember that sometimes some things execute faster than other stuff. And for example, here our player character might not be initialized yet when this initialized. So in order, I know there are better practices to work around this, but basically we're going to just wait for a second for everything to initialize, and then we're going to assign the value, which will be our player character as the enemy of this AI, to the memory of our brain. This is just, if it's not valid, just going to print on a screen that we haven't assigned our behavior tree asset yet. So how do we create a behavior tree? Let's go. I made a small folder here where I have my behavior tree Blackboard and my behavior tree itself. I'm going to create a new folder for just sake of testing and showing you guys how this is done. I'm going to put test behavior tree, and then we go here, artificial intelligence. As we can see here, we have the EQS, which we're going to use in this series as well, but we have the behavior tree and the Blackboard. Yeah, as I said before, the Blackboard asset stores all the data needed for a specific instance of an AI controller, which we just saw, and that will be referenced by the behavior tree. So let's make our behavior tree just for testing. I'm going to put BT as Unreal Engine convention says. Behavior tree test course, and we open it, and this is here is empty. Okay, so this is the behavior tree base tree I did before. You guys won't have this, but we have to assign a Blackboard. So we're going to really quick create a Blackboard component, which be here the Blackboard BB test course, and we assign it here. So now we have our brain and our memory. So we can see we can check the Blackboard, and as we can see, it's empty. All right, so we are going to go to our behavior tree, and instead of the one I had assigned before, we're going to assign this here, the test one I just made. There you go. Okay, so now nothing's going to happen because this has no logic here. I mean, I'm going to close this one for now. And yeah, this has nothing here. And it has nothing. It has no variables aside from this one, which is created by default. Oh, my bad. If the behavior tree, I couldn't show it like really well because I have a weird resolution screen and it wasn't right here. But yeah, this is how a behavior tree looks like when you just create it, and this is how the Blackboard component looks like when you just create it. Okay, so now I assigned it to my I mean, not to the controller, and as we can see, nothing's going to happen. It's just going to stay still there for eternity. So what does this mean? It means that we have to add some logic, which I had here, but okay. Oh, give me a second. So let's see the elements in depth. First, we have the selector. It's a composite. We have two kind of composites, I mean three, but we're going to use two for now for the sake of simplicity. We have a selector and a sequence. What's the difference between these two? Selector, as we said, as it says here, selector nodes executes their children or leaps from left to right, as I said before, in the execution order, and will stop executing children when one of their children succeeds. It means it has you have a choice. You can have two or three or four. For example, the first choice, it doesn't work, so it's going to jump straight to checking the second one. If the second one succeeds, then it's going to stop there and it's going to execute that. And the sequence is the opposite, quite the opposite. this, as it says here, execute their children from left to right, and will stop executing its children when one of their children fails. If child fails, then the sequence fails. If all sequence children succeed, then the sequence succeeds. Uh, in shorter words, what this does is you have, for example, 1, 2, 3. We want to grab a soda pop. So first the AI is going to look at the soda pop, is going to check if the soda pop exists there, and then it's going to do the task of grabbing that soda pop. But what happens if the soda pop doesn't exist? It's going to look and it's going to find nothing. So the sequence is going to fail, and it's going to re-execute. That's the difference with the selector. As the name says, it selects A or B, and this executes 1, 2, 3, 4, 5, and whatever your task elements have. What else do we have? Decorators. We're not going to use this today, but it's good to know that this exists because it's really fundamental in our AI system. It's the conditionals. It's a sort of branch node. If you guys know the branch or if statements in if or else in programming, determines if a composite remembers the sequence or the selectors, if a composite can be executed or not. For example, we can have the creator to check a range, attack range. We can have a selector that's going to check if the AI is going to attack or it's going to patrol. It's going to check, I mean not patrol, just chasing us. It can check a bool value if the AI is within attack range, and if it's within attack range, it's going to execute in the selector the attack task. If not, it's going to execute the chase or move to player task. That's the decorator. It's basically an if statement or a branch node. And we have the services. This is a task. I mean, it's not a task, but it's a procedure that executes periodically based on time intervals, such as a tick. Mostly used in background tasks to retrieve and update data. We can use this, for example, to check if we have an enemy actor assigned to our blackboard, or if we are, or what the actual range or distance towards the player the AI has. That sort of things we can assign to timer or tick value that executes periodically in order to check data can be done within a service. But that's a bit more advanced, and we're going to check that on lesson 2. And the task is, as the name says, the actions to execute: attack, patrol, take cover, flee, or grab a soda pop. That's a task. Task is where we capsule this logic for the AI to do stuff. Yeah, this is how it basically. This is how it looks. The blue ones. Let me see if I can do zoom here. Oh, which, yeah, here we have it. Oops. Yeah, the blue ones are the decorators. For example, here it has line of sight. It's going to check if has line of sight. It might be like a bool value in our blackboard. It checks if it's true, and if it's set, it executes the sequence of chasing the player. And we have here on the other hand. Let me move this. Ouch. How do I move it? My bad. Oops. Here we have a service. The services are these green elements. Here we have the service of checking the tag range, as I said before, and this set default focus is this default one. Just don't think about it yet. And based on this, the logic down here is going to retrieve the data, but this is how our systems are going to look, maybe a lesson 2 or 3. So it's good to know that the tasks are this purple ones, the blue ones are the conditionals within our composites, and the green ones are the services, which is periodically execute procedures. Oops, my cat is here. Okay, so let's jump into programming our first behavior tree. So we're going to use a sequence which will be called Oh, and as an advice, always put your node names in order for you to understand it on the Gleampool debugger we're going to use in the next class. It's always good to know what the behavior tree is executing, and names are crucial to that. So we're going to name this move to actor sequence. We can also comment here. We're going to do that later. The root always has to be connected something. Okay, so in order for this to work, we have to do the following things. The AI has to know it has an enemy. The enemy in this case will be the player. It has to be, the brain has to know. The memory has to be the value stored in order for this to know where to head to. Because remember, we're going this really simple today, and we're just going to chase the player endlessly. But in order to do that, Unreal Engine has a function, a task out of the box. It's called move to. What are the difference between this move to and move directly toward? I always recommend using this one because this one takes pathfinding as a variable. I mean, not a variable we can code, but it's going to, in order like to know where to head to, it's going to take pathfinding as something important and relevant to it. And this will just go straight to the target, ignoring pathfinding. It says on a straight line, without regard to any navigation system. It's recommended to use this one. All right, so we have to connect this to this. So as we can see here, we have the 0 and the 1. These numbers show us the order of execution of our behavior tree. So we have to move to. We still don't have any target assigned. We're going to do that now in a few minutes. And we can, when we arrive to our player, we have to wait a bit for it to not just be endlessly chasing us. I mean, you can do it, but we need to see how this works now, like visually. And so we're going to use the other node that comes out of the box, our task that it's called wait. We also have wait Blackboard time, which we can use as well as like creating a float variable within our Blackboard and assigning it here. But today we're just going to keep it simple, and we're going to name this wait after arriving at enemy spot. Okay, so let's check the variables here we can tweak. First, we have the wait time. This is, as the name says, it's like a delay for it to end. We're just going to put 3 seconds. It's going to wait 3 seconds after this arrives where it has to go. And we have a random deviation, which, as the name says as well, for example, if I put 1, it can be like 4 seconds or 2 seconds in a random way. We're just keep it 0 for now. And now it has a number 2. So it goes to sequence, moves to the actor. When it arrives to the actor, it's going to wait, and so on. Okay, now the Blackboard enters the game. This move to, we're going to name it move to detected enemy actor. For now, we're just going to hard code this, and it says it has 2 really important parameters. The acceptable radius. It's it's a threshold, as the description says. But for example, if it has, it makes us a radius around the detected enemy actor. So when it overlaps the radius, it's going to succeed and enter the wait. If it's 5, it's going to be real small, so it's going to crash against us, and that's not cool. But we're going to put like 300, so it's like a more organic. It looks more organic. So it's going to take like 300 units and real units when it's going towards us, and when it's 3 units away from us, it's going to stop and wait. And then we can implement some range stack or whatever we're going to program this course. So that's the base logic. But the other important parameter is this, this Blackboard key. It has self-actor by default, but of course, it means that it's going to move to itself, so it makes no sense. So it needs a reference to ourselves as an enemy. How can we do this? We jump straight into a Blackboard. Here we have a Blackboard. And we create a new key. Keys are variables. And it has all these types. We have object here. So we create an object key. We call this target actor. And of course, we can't assign yet a value, but we can assign a class. For now, it's going to be just right as this, because we assign this on Blueprint or C++, like the value itself. All right, so when we create this, we can go here, and the Blackboard key, in the Blackboard key, we assign, oops, let me save. Oh. Oh. No, give me a second. I have to save it. Ah, 1 second. Base class. How's it called? Player. We can put a character maybe. Yes. Yeah, here it shows. Yeah, as this is as the keys are object, which is the most abstract and basic class of Unreal Engine, it needs to be a pawn or a character in order for this to know that it exists physically in the world. So it has coordinates. So remember to, how did I fix it? When I created it, it has a key type, which of course will be object, but you have to assign a base class, and in this case, character will be fine. This only happens with objects if it's a vector, which can be like a coordinate or a float value. You don't have to do this, but if you wanted to go straight to move to an actor, you have to assign. It can be pawn or character, because those classes, or actor, actually it can be an actor, I think, because an actor is something that physically exists in the world. Let me check. Yeah, it can be an actor. So remember to always go one step down of object and assign something, a class actor, which exists on the world, for this key to be compatible with the task. All right, so now we have this, but if we run it, nothing is happening yet. As we can see here, it says none, and we can check visually what's happening in the behavior tree. But what's happening here is that the target actor has no reference to anything, so it doesn't know where to move to. Now is where we have to jump into our C++ or Blueprint in this case. As I said before, let's check this on our AI-based controller. Always remember that behavior trees are run in our controller, AI controller. We assign our test course behavior tree here. With this node, we run the behavior tree and we waited a bit for initialization of our player, because we assigned this manually for now. Of course, this will be changed later with the AI perception and coordinates and stuff. But for now, in order to see what happens visually, we wait 1 second for the player to exist in the world, and we use this node. All right, I'm going to explain this briefly. First, we need to get the Blackboard. Get Blackboard. You can use this. I prefer to use this function. This returns the Blackboard component of the behavior tree this AI controller is executing, which will be this. And as I did here, up here, we just grab the return value and set value as. This is really interesting because, as I showed before, when we create keys here, we have different values. Here we can set value as all these types Unreal Engine Blackboard component provides us: Boolean, class, enum, floats, name, objects, rotator, string, and vector. In this case, we're going to use an object because it's an actor, which will be our player character. And of course, we use the get player character node. And this will be the object we're going to pass to the memory of our brain, which is the Blackboard component. But this needs the name of the key. This has to be exactly how it's written here. If not, it's not going to find the key and it's going to fail. Nothing's going to be passed. How we do this? I know it's bad to hard code. We can use a parameter for this, which we're going to do later. But for now, we can use this node, which is make literal name. And we write here the name of the key we just created, which was target actor, I think it was. See, it's really easy to forget. Yeah, it was target actor. This was the old one of my old behavior tree. I'm just going to just move it here. So let's see what happens now. We have our behavior tree here, down here to check the variables. Oops, my camera is bothering there, I think. Yeah, now you can see it. All right, so now, as we see, down here is moving straight to us. It overlaps within 300 Unreal units and then comes again to us, and so on. Let's wait, and it's within 300 units, and we'll keep on waiting until we are further from the AI. All right, that was our first AI coding experience. So let's see now the conclusions of this short lesson. Unreal Engine has an AI system out of the box, which is the behavior tree and task system as we just saw today. This system has some private requirements, such as the navigation mesh. Remember, it's this green thing, which are the boundaries where our AI can move within. If you can't see it, I mean, you can add it here, nav mesh, bounce volume, and press the P letter in order to see this on your viewport. This is it's have nav mesh is the AI controller class, and a blackboard and I mean the behavior tree. My bad, it's a typo. And behavior tree class. Remember, the blackboard is the memory of the brain, and the brain is the behavior tree. Behavior trees are made of small elements coexist together, such as composites, which are these selector sequences. The selectors being a choice and the sequence being, well, a sequence, and it executes 1, 2, 3, 4, 5, as was said before. It has decorators, which were these conditionals, which we didn't use today for sake of simplicity, as well as services, which were these periodical tasks, periodical procedures, and tasks, which these ones are tasks. Today we use the Unreal Engine out of the box tasks, but we're going to code or custom tasks on the next lesson. And you can find out more in Epic's documentation regarding behavior trees. That was the first episode of this AI series. Thank you guys for your time. See you next time.